Let's Go Race, the channel for virtual motorsport.
Hello and welcome to a new video on my YouTube channel. First ein Info to my German-speaking viewers. Dieses Video ist auch mit deutschem Kommentar verfügbar. Der Link zum deutschsprachigen Video findet ihr in der Videobeschreibung. This video is about the Simtag Simulator's Ashley Hydraulic 3-pedal set. First, I will show you the pedals in detail in this video. I will talk about the different components used and included in the package, say something about the materials, and explain how the pedals feel. After that, I will give a conclusion about the pedals. And at the end of the video, I will do a test drive with the pedals on my simulator. The package includes the 3-pedal set, different springs to adjust the pedals according to your wishes, a connection cable, screws to attach the pedals to the simulator, and 3 adhesive pads which can be attached to the pedal plates. You'll receive more information about the different parts during the video. First, let's take a look at the materials and the workmanship of the pedals. The basis of the pedal set is a Tilton 600 pedal unit, so the basic construction of the pedals. Tilton pedals are used worldwide in the cars of many motorsport series, so Simtag uses the Tilton pedal unit and redesign it to use it on racing simulators. We have here a pedal unit with clutch, brake and throttle. As you would expect from Simtag, only the best materials are used. All parts are made of black anodized aluminium which were CNC machined directly at Simtag, and the workmanship of the materials is very good. The sensors and the measuring system are also of the highest quality, with systems from Bosch and ABB. For the hydraulic tanks, the Wilwood brand is used, as with the previous generations. This, in combination with the new Grenade system, a hydraulic push cylinder designed and built by Simtag, has led to a very high level of quality in this area. Let's start with the pedals. Each pedal has an adjustable pedal plate. These pedal plates can be mounted in different ways, so we can adjust the position of the pedal plates to our preferences. We can change the position of the pedal plates horizontally via the treads directly on the pedal. And via the mounting holes in the pedal plates, we can adjust the pedal plates vertically. Because the mounting holes are vertically offset on the pedal plate, we have a third adjustment option here. This is easy to see because the distance between the holes and the edge is different at the top and the bottom. Also included in the package are these 3 adhesive pads, which you can stick on the pedal plates. These adhesive pads have a rough surface. With these adhesive pads, you don't slip on the pedal plates and you have an extremely good grip on the pedal plates. Let's start with the throttle pedal. The resistance of the throttle pedal is generated by the spring on the pedal axis of rotation. Here we have a maximum resistance of slightly less than 4 kg with the spring. A spring with a lower resistance and a replacement spring are also included in the scope of delivery. The stiffness of the throttle pedal can also be changed by turning the nut on the axle of the throttle pedal. To reduce the stiffness, simply turn the nut anti-clockwise. This way, the discs in between are no longer pressed so hard and you have less resistance. However, you should only turn the nut anti-clockwise by a maximum of 2 turns. The pedal travel can be adjusted with the 2 golden treated rods. With the treated rod at the rear, we limit the pedal travel to the rear. And with the treated rod at the front, we define how far the throttle pedal may move forward. By turning the treated rod in or out, we then adjust the pedal travel. The throttle pedal is directly connected via a rod to the sensor, which transmits the position of the throttle pedal to the system. On the sensor, we can fix the rod in 2 positions. And directly on the pedal, we can also fix the rod in several positions. Depending on where we attach the rod, we change the reaction curve of the throttle pedal. So it is the same as when we change the reaction curve of the throttle pedal in the simulation. With a different position, the data sent to the simulation is more or less linear to the throttle pedal travel. The throttle feels very good and it is very precise to drive with the maximum resistance of just under 4 kg. In addition, we have several options to adjust the throttle to our liking. Let's continue with the clutch. The resistance of the clutch is generated by the slot spring. Here we have a resistance of about 18 kg with the blue spring. With the green spring included in the delivery, we have a resistance of about 11.6 kg. The golden treated rod allows us to adjust how far we can push the clutch. And via the nut on the back of the clutch, we can adjust how far the clutch can come forward. So depending on how far we turn in or out in a certain direction, we change the pedal travel of the clutch. At the clutch we also have a rod which is directly connected to a sensor. Here we have the possibility to mount the rod directly at the sensor at a different point in order to get a different reaction curve. Now we come to the heart of the pedal set, the brake. Here we have a hydraulic brake with a maximum brake pressure of about 150 kilograms to provide a realistic brake feel and pressure. Because the brake pedal is supposed to simulate a brake pedal from a real racing car, the brake pedal must be able to generate very high forces. This is because the force you have to generate on the brake pedal in a racing car cannot be compared to that of a road car. The specifications on the brake pedal are as follows. We have a pressure range of about 40 kilograms on the brake pedal. The maximum pressure that can be generated is 150 kilograms on the brake pedal when we use the full resistance. And the minimum pressure is about 110 kilograms. We adjust the brake with the help of this round part at the back of the pedals. If we turn clockwise, we increase the resistance. And if we turn anti-clockwise, we decrease the braking resistance. To show exactly how this works, I have to unscrew the part completely so that you can see what is underneath. As we can see, there is a flexible ball underneath with which we can adjust the resistance of the brake. The more we squeeze this ball, the more compressed the ball is and the more stiff the ball is, and therefore also our brake pedal. So if we turn our cover further down, we compress the ball and the resistance of the brake increases in the range of about 110 to 150 kilograms. The opposite happens of course when we turn the cover upwards with the help of the thread. Then the ball is no longer compressed and the brake resistance is reduced. In combination with the hydraulic system, we achieve such high resistance. This ball replaced the colorful rubber dampers of the previous versions of the Simtag pedals. We don't have to change rubber dampers to change the brake resistance, just turn the cover further down or up. This way we can adjust the brake pressure in a few seconds, stepwise according to our preferences. To position the brake pedal separately further forwards or backwards, we do this via the two golden threaded rods and nuts on the brake pedal. By turning clockwise or anti-clockwise, we change the position or the distance of the brake pedal. Of course, the pedal set also comes with a connection cable. Here we have the choice between a SimCube 2 connection cable to connect the pedals directly to the SimCube 2 base, or a USB cable with a Leo Bodnar circuit board to connect the pedals directly to the PC. I have the SimCube 2 connection cable here. With this, I can configure and adjust the pedals directly in the SimCube software. Once the pedals are connected to the SimCube system, we can adjust them in the SimCube software. In the SimCube software, we have to click on Configure Analog Inputs under the settings. Then, a menu opens in which we can configure the pedals. Under each section, we only have to select the correct pin and we can configure the pedal travel. Under Raw Value, we see the current position of the respective pedal. In this case, the position when the pedal is not pressed. Under Min Value, we enter the percentage from which point the pedal should react, or at what point the pedal should send data to the simulation. So we manually set the beginning of the pedal travel. To set max value, we have to press the respective pedal completely down, and then enter the percentage as we want the pedal to be set. For the throttle pedal, we must not forget to mirror everything via the invert box. On the pedals, we have two additional XLR connectors. Here you can connect the handbrake to one connector and the shifter to the other connector directly via the Simtag pedals. With the SimCube cable, you can then also configure this like the pedals in the software. Now I would like to demonstrate the strength, or rather the adjustable range of the brake. To do this, I will set the brake once with a low resistance and once with a high and therefore a harder resistance. After that, I will also drive a full lap and direct comparison on the Nürburgring. As you can see, the pedal travel is slightly longer with the low resistance than with the high resistance, because we can push the pedal significantly further because of the lower resistance. Nevertheless, the pedal travel is set in the SimLab software as good as the same. So we don't necessarily have to reconfigure the pedal travel after adjusting the pedal strength. The difference of 40 kg in braking resistance is clearly noticeable, especially when you change from about 110 kg to about 150 kg. Compared to the low resistance setting, at the beginning it feels like you are pushing against the wall with the maximum brake resistance setting. Just to illustrate a little how big the difference is between the low and the high brake pressure setting. But after a few laps you get used to it very quickly. In my case, when I drive GT3 or Formula cars, I prefer to drive with a very high resistance. I prefer to use a low brake resistance when I use the clutch, or in old cars where you use the heel and toe technique, so when you use the brake and throttle pedal at the same time. That's all there is to say about the Simtag Simulator's Ashley Hydraulic 3-pedal set. Now we come to the final conclusion and the cost of the pedals. The Simtag Simulator's Hydraulic Ashley 3-pedal set costs €2,606 including VAT and free shipping. You can also add cables for a handbrake and a shifter, but you have to ask Simtag for the price. You can also have a pedal bracket with footrest made by Simtag. You can choose between the non-adjustable version for €106 and the adjustable version for €166 including the Sparko seat slider. Now on to the conclusion. The quality of the pedals is as with the previous versions at an absolute top level. Only high quality and stable materials were used, which are also beautiful finished. Also, only the best products were used for the individual components. A pedal unit from Tilton, sensors from ABB and Bosch, or hydraulic tanks from Wilwood. The selection of such premium brands guarantees the highest precision. With a maximum resistance of just under 4 kilograms, the throttle pedal is very easy to dose and control. With the various customization options, we can further adapt the throttle to our needs and preferences. I am also very impressed with the clutch, especially because of the high resistance of about 18 kilograms with the blue spring or 11.6 kilograms with the green spring. The clutch can be used very precisely. With the clutch, we also have a few customization options with which we can adapt the pedal to our needs and preferences. But the heart of the pedal set is of course the brake. And here Simtag has more than surpassed itself. With a maximum brake pressure of up to 150 kilograms and an adjustable range of 40 kilograms, you can reproduce the brake resistance of any race car 1-to-1 with this pedal set. With the new adjustment option, this adjustment of the braking resistance can be done in just a few seconds. So if you change from a GT4 car to a Formula 1 car, you can change the brake from low resistance to high resistance in just a few seconds by turning the red cover. But it wasn't just the adjustability that convinced me about the brake. The brake pedal can be operated very smoothly and precisely because of the hydraulic unit, despite the high brake resistance. Overall, this is probably the best brake pedal currently available on the market. I hope you enjoyed the video and I was able to answer all your questions. If you have any further questions, please write them into the comments. A link to the pedals is also in the video description. Now we come to a small test drive with the Audi V8 DTM on the Nürburgring with the simulation race room. I will drive with the softest brake pedal setting and the hard clutch spring. Have fun with it and see you next time.